Welcome to your comprehensive interactive study breakdown on the chemistry of acids. This topic is a cornerstone of GCSE chemistry, bridging qualitative observations with quantitative analysis. In this video, we will explore the precise definitions of acids and alkalis, the logarithmic pH scale, the 4 key reactions of acids, and how to perform titration calculations. By the end, you'll be ready to tackle any exam question, from simple definitions to complex 6-mark calculations. Let's map out the core concepts. An acid is defined as a substance that produces hydrogen ions in aqueous solution. An alkali is a soluble base that produces hydroxide ions. The pH scale measures acidity, and crucially, it is logarithmic. A decrease of 1 pH unit means a 10-fold increase in hydrogen ion concentration. Strong acids like hydrochloric acid ionize completely, while weak acids like ethanoic acid only partially ionize. Turning to our core study notes, acids undergo 4 key reactions. With metals, they produce a salt and hydrogen gas. With bases, metal oxides or hydroxides, they form a salt and water. With alkalis, the reaction is neutralization, producing a salt and water only. And with carbonates, they yield a salt, water, and carbon dioxide. Memorize these general equations and be able to write specific examples. Now let's walk through the titration procedure, a core practical. First, rinse and fill the burette with the acid of known concentration. Use a pipette to transfer exactly 25 cubic centimeters of alkali into a conical flask and add a few drops of indicator. Slowly add the acid from the burette while swirling until the indicator just changes color. This is the end point. Record the volume of acid used and repeat until you have concordant results within 0.1 cubic centimeters. Let's work through a typical titration calculation. We have 25.0 cubic centimeters of 0.100 mol dm cubed hydrochloric acid neutralizing 20.0 cubic centimeters of sodium hydroxide. First, write the balanced equation, HCl plus NaOH gives NaCl plus H2O. Calculate moles of acid. Concentration times volume in dm cubed gives 0.000250 moles. The mole ratio is 1:1, so moles of alkali are also 0.00250. Finally, concentration of NaOH equals moles divided by volume in dm cubed, giving 0.125 mol dm cubed. Always show your working and include units. Watch out for common pitfalls. A common mistake is confusing strong with concentrated. Strength refers to the degree of ionization, while concentration is about the amount of acid per volume. Always convert volumes from cubic centimeter to dm cubed by dividing by 1000. For neutralization, the ionic equation is H plus O gives H2O. And remember, an alkali is a soluble base, so not all bases are alkalis. To wrap up, remember the precise definitions of acids and alkalis. Understand that the pH scale is logarithmic. Know the 4 key reactions of acids and be able to write balanced equations. Master titration calculations by converting volumes, calculating moles, and using mole ratios. And finally, avoid confusing strength with concentration. With these tools, you are ready to excel in your exams. Keep revising and good luck!